right, dudes, we're getting this party started at exactly 2:30 because we took a 15-minute break at the beginning of class. Yeah, all right, cool. All right, so check this out. We're covering molar mass. The molar mass, like for example, if we have CH4, which is, what is CH4 again? It would be methane. That's right. I was going to ask, Celeste, what is CH4? But that's methane. That is cow poop, or not even cow poop. It's funny. What is the major contribution of methane gases in the United States? And like the second most major contribution of methane gases in the United States is cow poop, is cows farting. No, I kid you not.
President. Oh wow, that's
yeah, like cows farting. Anyway, methane gas is CH4. Okay. And if I want the molar mass of this thing, dude, what are you doing?
I was looking at the big blue button, and then I went back to Google methane.
Well, you don't need to go on to big blue button. You're right here, dude. All right.
Oh, I guess so.
All right. Methane gas is CH4. And what I want is the molar mass. The molar mass is how many grams for every mole of this stuff that you have. Remember, the mole is what we use to group these things inside of larger groups, or inside of groups. And then when we have a reasonable sized groups, we can measure how many grams that thing is. Does that make sense?
Yeah.
All right, cool. So methane gas, to get this answer, all we would need to do is we know that 1 mole of carbon is, well, I don't know. We have to look it up on the periodic table. Actually, I can tell you what it is. It's 12.01 grams per mole. That's the little number on the bottom of the periodic table.
Okay.
And hydrogen is 1.004, I think it is.
I gotta pull up my periodic table now.
Double check that one for me. What is the molar the molar mass of hydrogen? I'll pull up a periodic table too.
Interwebs are slows.
1.008. That's what it was. It's been a while since I did this kind of stuff. All right.
My picture is still loading.
So we have 1 carbon and 4 hydrogens. Now, since we have 4 hydrogens, we need to multiply this by 4. Got it? And then we want to figure out how much total this is. So this is 1 carbon, 4 hydrogens, and you just add that up. That's how you get the molar mass. Now, someone used their calculator. What is 12.01 plus 4 times 1.08?
What was that?
12.01 plus 4 times 1.008, and the 4 times 1.008 you have to do first, and then the
times 4.008.
No, 4 times 1.008
times 1.008.
Yeah.
What have I done? Okay, okay. Someone else do it.
Come on, you guys.
Help.
Well, what did you get?
Answer.
I'm guessing the answer is about 16.
16.01.
16.042. All right.
042. Or, no, it's 042. That's a much better answer.
16.042 grams per mole. Now, actually, Genesis, this is helping you out with this s'mores lab, I just realized. Because in the s'mores lab, I gave you the mass of 4 marshmallows and the mass of 4... I gave you this weird thing where I said, let's let an Anastasio equal the number 4. So then I gave you the mass of 4... of 1 Anastasio of marshmallows. So really what I gave you was the mass of 4 marshmallows, right?
Right.
And I forgot what that number was. It was some, it's somewhere around here.
Our labs at home.
And I give you let's make it up. I don't know. Let's say 12 or 8 grams per Anastasio of marshmallows. Well, I'm kind of doing the same thing. Because what I'm doing here is, what we're dealing with here is this number over here, these small little numbers, the hydrogen with the 1.008 grams per mole, the molar mass of it, is saying if I gather up 1 mole of something, this is how many grams this weighs. This is exactly what I did in the lab. It's just I'm using a much smaller number.
Yeah.
Instead of 6.0221 times 10 to the 23rd power, I'm using the number 4. Does that make sense? And then I asked you to do something like, I think I asked you to tell me what is the total mass of SMMOR, something like that, right?
Small, and then there was just
And then there was like a 2 over here and a 3 over here. And then so what you had to do was you take the graham crackers, take the marshmallow, the molar mass, multiply it by 2, take the chocolate, multiply it by 3, and then add them all up together. Does that make sense? Well, that's actually exactly what you're doing here. For this methane gas, we have 1 carbon, so you keep it 1. But then you have 4 hydrogens, so you multiply the hydrogen by 4, and that kind of stuff like that. What do you mean I tried to spell s'more? I successfully spelled s'more.
SMOR. That's how I always thought you spelled s'more.
Yeah, well, I'm close. I've successfully tried to spell.
Oh, no, I was in a spelling test once, and I spelled coffee with a K.
Yeah. All right. All right. Cool. So actually, yeah, I'll help you out with your lab now because, see, the point of me doing the lab was to get you folks to start thinking in terms of this. This is how you start thinking about it, and this is kind of like, yeah, this is why I did the s'mores lab with you, so that way I can teach you the molar mass stuff. All right, calculate the molar mass of Juglone. Wait, all right, let's see. Juglone is a dye known for centuries to produce the husk, or from the husk of black walnuts. It is also a natural herbicide, a weed killer, and it kills off competitive plants around black walnut trees, but does not affect the grass and non-competitive plants. The formula for Juglone is C10H6O3. All right. C10H6O3. What is the molar mass of Juglone? All right, well, here's how you do it. Ready? Carbon, if you look it up, is 12.01. How many carbons are there in Juglone? I don't know if I'm pronouncing that correct anyway.
Wasn't it 10?
10.
Yeah.
So you multiply this number by 10.
There's 1 point.
Now we're going to add the hydrogens. There is 1.008. That's the molar mass of hydrogen, but how many hydrogens do you have?
6. So
6, so you multiply that by 6. And then you add, I think oxygen is exactly 16.00.
It's actually 15.999.
15.999, but when you round it off to two digits, it's 16.00.
All right, I'll give you that.
All right. And then there's 3 of those. So you plug it into your calculator, which, why don't we just use Google as our calculator? And you know what? For some reason, my Firefox doesn't like Google. They just don't play well together. So let's do, what did I do? 10 times 12.01 plus 6 times, what was it? 1.008 plus 3, was it 3? Times 16?
I think so.
And you get 174.148. 174.148. Does that make sense to you? Makes sense to me.
Makes sense to me.
This is actually not so bad stuff. All right. A sample of this many grams of pure Juglone is extracted from the black walnut husk. How many moles of Juglone is represented in this? Does this sample represent? Okay, cool. So this time we know that 1 mole of this stuff is equal to 174.148 grams of this stuff. We can now use this as a conversion factor. And remember, we taught you about conversion factors in Chapter 1. So check this out. If they told us that there are 1.56 grams of this stuff, 1.56 times 10 to the negative 2 grams of this stuff, how many moles is that? Well, I know that 1 mole is equal to this, right? So I'm going to do that conversion game that I do. I think that maybe when I first introduced to you, I made it something like this.
I think I remember that.
All right. Now, I'm going to either have the 174.148 grams on top or on the bottom. Which one do I have? Bradley's asking why the negative 2. And the reason why is because in the problem they told me 1.56 times 10 to the negative 2. Because that's what they gave me. Okay.
Yeah, I see it.
All right. So now the 174, am I going to have that on top or the bottom?
I guess you'd have that on top.
You're going to have it on the bottom. 174.148 grams on the bottom. Yeah, you're right. You're right. You moved the decimal place to the left, but let's deal with that later. But here's my question is, why do I have it on the bottom?
That's my question.
Why do I have the 174 grams on the bottom?
Maybe, are you...
Well, remember what they're asking us for. How many moles of Juglon does it, blah, blah, blah. How many moles? We want moles as our answer. Do we want grams anywhere in our answer? No.
We just want moles.
So what's nice is if I have the 174.148 grams on the bottom, then it cancels out with this grams on the top, which is the point.
Okay.
Does that make sense? Makes sense to me, because that's what Bradley said. Bradley says, "Oh, you just want to cancel it."
I think I did this a long time ago.
No, you've never done this type of calculation, but this is just like you do in the conversions.
Okay.
When we were converting, like, feet to inches and that kind of stuff.
Yeah.
Or miles to centimeters.
Yeah, which is awful.
Okay. So basically, you take your 1.56 divided by 174.148. All right, so let's do that. 1.56 divided by 174. What is it? 148. And I'll tell you what. Yeah, let's do it like this. It would be 8.96 times 10 to the negative 3. 8.96 times 10 to the negative 3. And I also have times 10 to the negative 2. I didn't do anything with that times 10 to the negative 2, so it's still there.
Yeah.
And then my answer, I could have written down 0.80 or 0.00896, but I'd rather write 8.96 times 10 to the negative 3. Are we cool? So Bradley, no, this right here. Okay, here's the problem. Juglone is a dye known for centuries, blah, 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 blah. And here's the equation. C10H6O3. A sample of 1.56 times 10 to the negative 2 grams of pure Juglone extract, or is extracted from black walnut. So what we want to figure out is how many moles of this stuff there are. Does that make sense?
They're not lying. There is such thing as Juglone.
All right. So what we did was we have 8.96 times 10 to the negative 3. And we also have times 10 to the negative 2. So I'm going to combine those. 8.96 times 10 to the negative 5. And my answer is moles of C10H6O3. How do you find the grams of a single element? Okay, Bradley, to find the grams of any single element, I look at the periodic table. And here's the periodic table. The number down there on the very bottom right there, it's hard to see, but when you look it up on your periodic table, you'll be able to see it fine. What space is that in? It's the number on the bottom. It's called the molar mass. Now, you're talking about what is the units of that. All of the units for this is grams per mole. So hydrogen is 1 gram for 1 mole of atoms. Carbon is 12.01 grams for 1 mole of carbon atoms. I feel like you're getting confused. No, a mole is not a cubic measurement. A mole is a grouping of numbers. I feel like you're getting confused with this moles concept.
Yeah.
All right.
1 mole. How many is 1 mole?
All right, here. Let's do this. Okay. Let's go back to the s'mores lab. All right. Now in the s'mores lab, if I were to give you like a marshmallow, the weight of a marshmallow, right? And let's not think about the small little marshmallows, not the big ones. Okay. Now, if I were to give you the weight of 1 marshmallow, right? Do you have any scale in your house that could weigh that?
I don't.
Do you even have access to a scale that could probably weigh that?
1 small little marshmallow?
1 small marshmallow.
I don't. No.
Not really. I mean,
someone may.
A few people do.
I mean, I guess.
I'm talking about the small marshmallows, not the big ones. The ones you use in Thanksgiving. All right. I don't have a scale that will, really well measure that. You know what I mean? So what I do is, because it's so small, you know what I mean? It would be like, I don't know, let's just make it up, like, it would be like 2 times 10 to the negative 2 grams. I'm making it up. I'm sure that marshmallow's way heavier than that, but I mean, they're mostly air, so what are you going to do? And sugar. So it'd be something really small, like 0.02 grams. Okay? And I don't have a scale that can measure that.
I don't.
So here's the thing. All right. Here's what I did then. In the s'mores lab, I said, all right, what I'm going to do is I'm going to combine these to make them like one Anastasio worth. So what I did was I said, all right, I'm going to combine these to make them 4 of these things, right? And then if I have a group of 4 of them together, then you could weigh them. Then it's a reasonable amount to weigh. Does that make sense?
Yeah.
Like I could maybe find a scale that could measure that. 4 marshmallows, but not 1 marshmallow. Does that make sense? Bradley, are you understanding kind of where we're going with that? Okay. Here's the problem. We're dealing with atoms. Freaking atoms here.
Those are smaller than marshmallows.
Like, way smaller than a single marshmallow. Now, if I'd made a periodic table where I just did the grams of 1 atom, here's the mass of 1 atom. 1 atom for this weighs this, 1 atom for this weighs this, 1 atom for this weighs this. We're talking about an incredibly small number. You would have like times 10 to the negative 40 grams or times 10 to the negative whatever on everything. And it would just make your periodic table ridiculous, right? And then I would say, oh, I want you to measure out. You need a scale that can measure that. There are no scales that can measure that. So what we do is instead of grouping them into a group of 4, we group them into a much bigger group. That bigger group is the mole, 6.022 times 10 to the 23rd power. Now, that many moles of atoms that would have a reasonable weight, something that I could measure in the lab.
How would you get exactly 1 mole of a bunch of atoms?
Well, I'll tell you. You would measure out exactly 1.0079 grams of hydrogen, and that's how you know how many moles of atoms there are in there.
That makes sense.
You know that there are 6.022 times 10 to the 23rd power moles.
And you could,
or not moles, there is exactly 1 mole, which consists of 6.022 times 10 to the 23rd atoms of hydrogen.
Right. Okay.
So that amount, that large grouping of hydrogen atoms, it would weigh 1 gram. For carbon, it would weigh 12 grams. For oxygen, if I had exactly 6.022 times 10 to the 23rd molecules of oxygen, it would weigh about 15.9994 grams. Or about 16 grams.
About 16, yeah.
So that's where we're getting these numbers from. We're clumping them together, and we're measuring the weight of the group, or the mass of the group of it. And the size of the group is 6.022 times 10 to the 23rd power.
Okay.
Does that make sense?
Makes sense to me. Still don't get why someone invented the mole.
Oh. Instead of using a cubic centimeter? Well, okay.
That would still be really small.
I see what you're saying, Bradley. That would be a good idea. You would say, I want to... I actually agree with you. I see what you're saying completely, and that's actually a very creative and good idea.
That wasn't me. Okay,
No, that's my wife. All right. That's a very creative and good idea. Maybe what Bradley is saying is, let's get a cubic centimeter, which is also known as 1 liter, or 1 milliliter.
1 milliliter.
1 milliliter is exactly a cubic centimeter. So let's take hydrogen, and we'll pour out 1 milliliter of it, and we'll weigh that. That would be a good idea. You know what I mean? Here's the thing, though, is different elements have different densities. So the volumes are going to be different across the board. And I think that we even had people make periodic scaling things for the density, so you can kind of see the different slopes and everything for that. So different elements have different densities, so you'll have different amounts of molecules that are inside of those cubic centimeters, each of your cubic centimeters. They won't all have the same amount of molecules. Now, where did someone get the mole? How did they come up with it? To be honest with you, I don't know. I don't know the experiment that they came up with it. But here's how they defined it. They said, I'm going to take carbon-12, exactly carbon-12. And what I'm going to do is I'm going to measure out 12 grams of this stuff, of carbon-12. And I'm going to say, I'm going to, figure out how many molecules exist in that space. And apparently Avogadro came up with, or somebody came up with 6.022 times 10 to the 23rd power number of molecules that they're dealing with. I don't know why they do that, how they came up with that. I probably should know, but I don't.
I'm sure there's a whole
All right,
lot
let's
of
see.
biography on it.
Calcite. I actually have some calcite over here. It's CaCO3. Okay. A certain amount of calcium contains 4.86 moles. What is the mass of this in grams? What is the mass? Okay. So, if I have calcite, which is CaCO3, CaCO3, oops, CO3, and I have exactly 4.86 moles. Of calcite. How many grams? What is Mr. Mole?
I was, what? Mr. Mole.
Oh. I don't know what you're talking about. All right. If I have exactly 4.86 moles of calcite, how many grams is that going to weigh? Fair enough question, right?
Yeah.
All right. First of all, we kind of need to do some side work here. So what we need to do is we need to figure out our conversion for calcite. So what I want you to do is, let's look up calcium. What is the molar mass of calcium? You have your periodic table up here?
Of calcium is
40.
where am I?
40.078. 40.078. You look it up in a periodic table, you look at the number below it, done. Got it? Carbon we know as 12.01. And oxygen, do you guys have that memorized? 16.
15.
After a while, you'll memorize some of these numbers.
Okay.
Especially carbon, hydrogen, and
The
oxygen.
ones you'll use
Those
a lot.
ones always come up. And maybe nitrogen. Yeah. All right. All right. So we need to add up all of these numbers, except before you add them all up, multiply the 16 times 3. So someone do that on their calculator. And what you get is, all right, let's do it. 40.078 plus, was it 16 times 3 plus 12.01. 100.008. Got it. 100.008.
Isn't Mr. Mole the bad guy in Thumbelina?
I think so. All right, anyway. So this is calcite. This is how many grams 1 mole of calcite atoms would weigh. 100.008 grams. All right? So what you do is, now I have 4.86 moles, and so what I want to do is I want to convert this to grams. I can use this now as my conversion factor. Now, here's the question. Do I put 100.008 grams on top or the bottom?
On the bottom. So if you're trying to get the moles, or are you trying to get the grams?
What
was the question?
I'm trying to get the grams.
Oh, then you put it on the top.
Well, yeah, exactly. I put it on the top. Well, here's the reason why. Because that puts the moles on the
On
bottom.
the bottom, and they cancel each other out.
Right. This is 100.008 grams per mole, so the mole's on the bottom. This mole cancels out with that mole, and then you end up getting 4.86 times 100.008, which I'm not going to use a calculator. I'm just going to guess it to be 486 grams.
Yeah.
I'm not going to deal with that 0.008. I'm just saying 100 times 4.86 is about a 486 grams. Are we cool? All right, so each element is 1/3 of a mole, or is each element the number of grams in a mole? Bradley, the way you explained it the second time is correct. On the periodic table, we've listed how many grams. Wait, where's my period? On the periodic table, we've listed how many grams 1 mole of that substance is. Just like in the s'mores lab, I've listed how many grams 1 Anastasio of that substance is. Does that make sense?
Yeah.
So this totally does relate back to our original thing. All right, let's see. Calculate the mass of a typical bee sting. Oh, okay, this is pretty cool. Isopropanol acetate is a compound responsible for the scent of bananas. A molecular model of isopropanol acetate is shown in the margin below. So this is isopentanol. Yeah, all right. Isopentanol acetate is, interestingly, bees release about 1 microgram of this compound when they sting. The resulting scent attracts other bees to join the attack. How many molecules of isopentanol acetate are released in a typical bee sting? How many atoms of carbon are present? Okay, so this is a good problem. That's the question. A bee stings you, and apparently it lets off a banana scent. Then all of the other bees smell the banana scent and say, ooh, let's sting that guy.
That would suck.
That totally sucks. All right.
Wouldn't they give off a honey scent?
You figure they would give out a honey scent, but maybe bees are much more attracted to fruit and yellow things, I'd imagine. So they're like, I smell banana.
Let's sting
I
the
smell
guy.
banana. Let's go sting it.
Don't bees die if they
I
sting?
wonder if bees sting bananas then, like quite often. Or I wonder if bees hang around bananas very often. Anyway, whatever. Okay, let's go. All right. So first of all, before we start the problem, we kind of got to do some side work. Have your calculators ready for me. We got to figure out what the molar mass of isopentenyl acetate is. So if I have C7, that would be 7 times carbon, which we know as 12.01, plus 14 times 1.008, plus 2 times 16.00. We're cool?
It's a pheromone. The smell of bananas is a pheromone that makes bees violent.
Weird. All right, Bradley, what are you talking about 3 moles? No. Each element is 1 mole. I have 1 mole, and the molar mass that I'm showing you is how many grams is in 1 mole, not 3 moles. When I add what together? Oh, okay. Well, technically, Bradley, for this one right here, this would be, oh, okay, all right. I get what your question is. What you're asking is, we've got 3 elements. When I'm adding them together, aren't I adding, finding out how many grams for 3 moles of stuff there are, because I'm adding all 3 elements together. Or let's make it easier. How's about this? You know this equation, right? H2O. Let's figure out the molar mass of water.
What's H2O?
You don't know what H2O is?
No, I'm kidding. I'm kidding.
All right. That would be 2 times 1.008 plus 1 times 16. This is pure H2O water. Can somebody do that for me? Actually, I'll tell you what it is. It's 18.016. Right?
160. Yeah.
Yeah, all right. So, what Bradley is saying is, hey, aren't there 2 moles of doesn't this represent the grams for 2 moles of water? Because you have 1 mole of hydrogen and 1 mole of oxygen, right?
Yes.
All right.
You have 2, and then
Let's do this. Can I introduce to you this weird concept called an Anastasio? I'm trying to make it a big thing nowadays. All right. Let's make this your oxygen. Okay? And what I did was an H2O, let's make it look like this. That's 2 H's and 1 big O. Got it? And then you have an H2O, and you got an H2O. You got another H2O here. And the reason why I'm introducing this concept of an Anastasio, which is a 4 as opposed to a mole, is because I don't want to draw out 6.022 times 10 to the 23rd power of these little things. I would be here for the rest of my life, and then I would tell my grandkids to do that, and then they would probably do that for the next 6 generations, and we would be drawing these little,
that would be a really cool family project.
It'd be horrible torture. All right, so I was introducing you to this concept of an Anastasio. So what I'm saying is, 1 Anastasio of hydrogen of water molecules is what I drew right here, right?
Yeah.
This is 1 Anastasio, which consists of 8 hydrogens altogether, right? And 4 oxygens altogether. Or 2 Anastasios of hydrogen, because eight hydrogen altogether is 2 Anastasios of hydrogen,
Yes.
and 1 Anastasio of oxygen, which is 4 oxygens. So look, this still is 1 mole of water that's all together, even though I'm multiplying the hydrogen by 2 and I'm multiplying the oxygen by 1. Does that make sense? Did that
Yes.
make more sense to you? I'm not dealing with nope. Okay.
Mr. Dalday, you must be 2 hydrogen ions bound together by an oxygen.
Uh,
What are you talking about?
what is the number next to 2? This right here that I underlined? It's 1.008.
That's the
I'm really struggling to break this down even more, but I feel like Bradley just got it. Did you get it?
oh, gold. What? It's not gold, that's water.
Yeah, no, it's not AU. It's
Ha, yeah. Someone
Alright.
got it.
all right. Wait, I don't remember what joke I said. All right.
My joke, not your joke.
Oh, okay.
You totally missed it. You would have loved it.
Oh shoot! How do I explain this any better? All right, check this out. I have. All right, here. I have. Let's pretend that a mole means the word 4.
4.
All right.
That's gonna. Oh man.
All right. Well, fine. We'll go back to Anastasio. All right. I have 1 Anastasio of water. Right.
That's 4 waters.
And I drew it for you. Okay? 1 Anastasio of water consists of how many Anastasios of hydrogen?
8 hydrogens.
No? How many Anastasios of hydrogen? It consists of 8 hydrogens
2
altogether.
Anastasios.
2
of hydrogen.
Anastasios of hydrogen. And how many? Not 8, 2. Because an Anastasio means 4.
So 8 divided by.
So 2 groupings of 4 is 8.
Whoa.
Yes. I'm making the numbers much smaller so that you can wrap your head around this.
I can see.
How many Anastasios of oxygen am I dealing with? I just gave you the number.
Just one.
1, because
One
I have
Anastasio
4 oxygens altogether.
of oxygen.
So even though I'm dealing with 3 Anastasios of this other stuff, it takes those 3 elements to make water. So even though I have 3, moles, 2 of those moles being of hydrogen and 1 of those moles being of oxygen, that only creates 1 mole or 1 Anastasio of water. Because a water consists of 1 oxygen and 2 hydrogens.
It's big, so it would be a compound. So you'd have.
Does this make sense to you?
It makes sense to me. I think.
All right.
Oh.
At that point, I'd say, I think I've explained it the best I can. I think that maybe with practice you'll get it better.
I'm feeling. Well, maybe it's just my mind playing with me because I got an answer right, so it's telling me I'm smart.
So then shouldn't each element be a fraction of the whole? I think that what you're wanting to say.
Oh, forget it.
No. I don't want you to be all frustrated. You're like, I get it. Don't I mean, because I'm not frustrated. I'm just really trying to explain this, and I feel like we're spending some time on it. But, all right, here, look, check this out. Okay, this is the picture for isopentenyl acetate. We'll go back to the bananas thing. Whoa! What happened?
That's not a picture of whatever you just said.
Look, for chemistry, I don't mind going slow because it's difficult. For math, I will go at the rate that I need to go. So I can slow down chemistry. I can extend this thing out to cover chapter 1, 2, and 3 in the first quarter. I don't mind. All right, here. we'll go back to the bee sting. This is isopentenyl acetate. Yeah, you can go. Make sure to watch the archive. I think I'm archiving this. I hope I am. I'd die if I'm not. Am I? Am I? Yeah, I am. All right.
All right.
All right. This is isopentenyl acetate. It's right here. Do you see it?
Yes.
Okay. How many carbons is that? By the way, the black ones are carbons.
That would be 1 3/4 Anastasios of.
Don't do it, Anastasia. It's just how many carbons?
I'm sorry. 7.
7. Good. How many hydrogens? It looks like there's...
Those are the red ones, I'm assuming.
No, the hydrogens are the white ones.
Oh. I see.
13?
13 or 14. There's one hiding.
There's
behind.
one hiding right behind here. There's actually 14. You can tell because it's C7H14O2.
Oh, well,
Got it?
There's that, yes.
All right. And then how many oxygens? Those are the red ones.
I'm just kidding. Yeah.
There's 2. Got it.
Okay.
All right. If I were to double this model, take this model, copy it in your head, and paste it. Got it?
Got it.
How many pairs of this model will I have?
Pair? Wait.
How many pairs?
Pairs. You'd have one,
Yes,
one
I'm switching the word
if you
again.
copy and paste, you'd have
I've had
one
pair.
One pair. Of
One
the
pair
model.
means 2,
Yeah.
right? And I copy and paste, and I just have 2 models.
So you-
I'd have one pair, right?
Yeah.
Which consists of how many pairs of carbon?
7 pairs of carbon.
7 pairs of carbon, because that would be 14 carbons altogether in
Yes.
my head, right? And so 7 of those, there would be 7 pairs, right?
Yeah.
And how many pairs of hydrogen?
14. Wait, no.
Yeah, 14, because there would be
Yeah.
28 hydrogens, and so 14 pairs, right?
That would be.
And
You'd have 2 pairs.
two pairs of oxygen. It's the same ratio, 7, 14, and 2, right? But it takes 7, 14, and 2 of these elements to make up one isopentenyl acetate. Does that make sense?
Yes. A little bit. But bees don't sting pears; they sting
All right.
bananas.
All right, well, whatever. Yeah, bananas and pears. Okay. So, check this out. C7H14O2. I need to figure out the molar mass of this thing. I've got 7 moles of carbon, 14 moles of hydrogen, and 2 moles of oxygen.
2 moles of oxygen.
Yeah. Somebody likes you.
Someone likes me. Who is it?
Bradley. All right.
He had be my type of friend.
Yep.
Friend. Okay.
He thinks that you've got a
I'm ahead.
funny. No, he thinks that you've got a funny wit about you.
I'm.
It's cool. You know, you should
witty.
come to class, and then we can kind of
I
go
should-
back and forth.
Come to class.
Well, I mean, you're in class, but you should come to
I'm in
class
class.
regularly, and then like we can go back and forth and make this a Mr. Dalday kind of like a Mr. Dalday Maston radio show or something like that.
Man, that's a bit too much pressure on me. I'm trying to figure out this whole mole thing as well.
No, I think this is cool. All right, so check this out.
It's Mondays and Wednesdays, right?
You can make Wednesdays.
I can make Wednesdays, not
All right,
Mondays.
all right. It's gonna be the Mr. Dalday Maston show on Wednesdays.
All right.
All right. 16.02, or yeah. So if I add all this up together, I can figure out the molar mass of isopentenyl acetate, which is 7 times 12. Oh, I put 6. 7 times 12 plus 14 times 1.008 plus 2 times 16.00, and you end up getting 130.182. So apparently, isopentenyl acetate is 130.182 grams for every 1 mole of that stuff.
Okay.
Now, I agree with you I agree with you, Bradley, that 1 mole of isopentenyl acetate is actually 7 moles of carbon and 14 moles of hydrogen and 2 moles of oxygen. So maybe it's like 16, 23 moles of stuff altogether. And you're right.
But it's all one compound. So you
Right,
only
right.
have one.
It's 23 moles of stuff, but it takes those 23 things, 7 carbons, 14 hydrogens, and 2 oxygens, to make one
whatever that
isopentenyl acetate.
So
That's
yeah.
what it means. I now figured out how to explain it.
I get it.
Good.
I get it.
All right. Good. We're done. All right.
I've been enlightened.
Good. No. Having these discussions
New
is really
Renaissance.
important.
New Renaissance.
All right. So, what did I start off with? I started off with, okay, apparently bees sting and they only release 1 times 10 to the negative 6
Yeah,
grams
it's
of this stuff.
Makes all of the bees
1
attack.
times 10 to the negative 6 grams of this stuff. How many atoms? Wait, what's going
They can't learn anymore. Head explosion.
Oh, no.
Learning-
We just.
learning's
I'll tell you what. Let me just finish
done
this
learning
example.
for the day. I have an appointment. See, this guy's smart. He comes up with an excuse. I have an appointment. I've got.
All right. I'll
I
finish
can't
this
learn
one
anymore. I have an
example.
appointment.
And then that's it. No, you can go, Bianca. I'll finish this one example, and then that's it, and then we're done for the day. Sound good? All right. So, I have this many grams of isopentenyl acetate inside of a bee sting. Got it? How many atoms is that? Well, here's what we do.
Okay.
By the way, is the number going to be big or small? What do you think?
I'm assuming it's gonna be big.
Yeah, because we're talking about atoms here.
Yeah.
Yeah.
There's got to be an easier way to do that.
Yeah, there is. I'll just make the.
Line a little bigger.
How do I make it bigger? That's a little bigger. Oh, I know what to do. Perfect.
Whoa.
I am
There we
so
go.
SMRT smart. All right.
Smart.
All right.
Do you eat SM?
No, we got to finish this because they have to go. They're rioting pretty soon. Okay. 1 times 10 to the negative 6 grams. That's how much isopentenyl acetate I have in one bee sting. How many moles of that stuff do I have? Well, I know that I can divide this by 130.182 grams, and that will give me how many moles I have. Because I know that conversion, because I have this right here. And the reason why I inverted it is because I want to put the grams on the bottom, because I want to cancel out this grams of that.
Moles. Yeah.
To get moles. Good. Awesome. Okay. Then what I can say is this is how many moles I'm talking about. What is this?
Oh,
What
no, we have a
is the-
question.
what does the 1.1 times 10 to the negative 6 come from? Okay,
was
that comes from the
The
question.
original problem.
The problem came from, it told us that one bee sting apparently weighs 1 times 10 to the negative 6 grams. Actually, it doesn't weigh
You have
that.
a
but
weight
it-
in bee stings?
no, but that's how much isopentenyl acetate is released in one bee sting. Got it?
Yes.
All right. So, this is how many moles I have, but that's not how many atoms I am dealing with. There's another conversion I need to do. How many atoms is in 1 mole of this stuff? I'll tell you. 6.022 times 10 to the 23rd atoms.
Where do you get 6.022 from?
That's Avogadro's number.
Oh. I'm
That's-
not going to remember that.
That's the definition of a mole. No,
That's
that
a
is
mole.
like the
6.022.
that's really the only number I
Times-
want you to memorize.
6.022 times 10 to the
23rd power.
23rd power.
Yeah.
I better write that down in my head.
That's the only number I really want you to memorize. You're not going to memorize. That's the only thing I need you to do.
Yeah, let me write that down on one of my flashcards.
Yeah, write it down on a flashcard. It's like the most important chemistry number.
Borrow that pen. It's not actually a pen.
If you leave my class and somebody asks you what is a mole, you better recite it, or else I'm going to boot you in the face.
But we've left your class.
I will track you down.
Go ahead and write that on my hand.
and I will take my slipper and rub it ever so gently across
So
to your
this doesn't
face.
None of these work.
Boot to the face. Yeah, exactly. There we go. BTTF. All right.
BTDF.
So all we got to do is plug this into our calculator. What is 1 times 6.022 divided by 130.182? Okay. 1 times 6.022 divided by 130.182. Was it 182? Yeah, 182. So I dealt with the numbers, and it was 4.62 times 10 to the negative 2. That's what Google gave me.
Google.
I just typed in 1 times 10, 6.022 divided by
Divided by.
130.182, which is 4.602 times 10 to the negative 2. I
guess
still got to deal with
seems right.
I still got to deal with this times 10 to the 23rd power. So
So it would just be.
Oh, and then the grams cancel out with the grams, the moles cancel out with the moles, and I have atoms left over, so the answer is in atoms.
So you'd have.
Let's combine these two guys right here. So it's 4.62 times 10 to the
21st
21 power.
power. The atoms.
That is how many atoms of isopentenyl acetate is in one bee sting.
That's a lot. Well, that's not really a lot, but it's. Is that a lot or is that not a lot? It's only 4 atoms.
Does that make sense? All right. There's one last part to this example problem, and this is where it kind of becomes really interesting too. Is they ask a second part. This is how many molecules of, or I'm sorry, I put atoms. It's molecules. It's the same kind of deal.
Atoms are molecules. Okay.
How many molecules of isopentenyl acetate is released in a typical bee sting? Done. How many atoms of carbon are present in that bee sting? So how much carbon is in there? All right, here's what you do.
What?
You know this is for isopentenyl acetate. This is the many grams, 130.182 grams for 1 mole of C7H14O2, right?
Right.
You can make this conversion easy if you're dealing with moles, and that's how you do it. 1 mole of C7H14O2, isopentenyl acetate, contains how many moles of carbon? This is actually I'm glad we had this whole big discussion with Bradley, because I'm realizing that this is actually becoming an important role. How many moles of carbon do I have in 1 mole of isopentenyl acetate?
Whatever 12.011 times 7 is.
No.
No?
7.
What?
For every 1
What?
mole of isopentenyl acetate, I have
Oh,
7 moles of carbon.
Oh, I done goofed. Oh,
Does that make sense?
Wow, that was you tricked me.
For every 1 amount of this model I have here, it comes with 7 black dots.
That's so ridiculously
Does that make sense?
complicated for the amount of complication we just did.
Now, my answer is in moles of carbon. That's not how much carbon atoms I have. How do I convert the carbon? If I have 7 moles of carbon,
Why do I need this?
what? Why do I need to know this? Because this is the way chemistry works. All right. Oh God, if a bee stung me. This is the last thing I'm gonna worry about.
Oh man.
Yeah. Oh man, if a bee stung me,
just
I
stung me.
know that I have 7 carbon atoms. How many? What do I have to do to make an antidote?
Dies.
Yeah. Yeah. All right, never mind. All right. See you. You can go.
Later.
How do I convert moles of carbon to atoms of carbon? 1 mole of carbon is how many atoms of carbon?
How many atoms of carbon? Is that what I just did?
Yeah, how
Could
many
be.
atoms of carbon are we dealing with? 1 mole of carbon is how many atoms of carbon?
Isn't it 12.011? Or am I doing it wrong again? I think I'm doing it wrong again.
No, it's right. There we go. Awesome, Bradley. I'm glad you said that. 6.022 times 10 to the 23rd atoms of carbon. Because 1 mole of anything is
1 mole of
6.022
anything
times 10 to the 23rd of
Oh.
that thing. If you want to convert moles or to, if you want to convert moles to how much it represents, it would be 6.022 times 10 to the 23rd of that stuff.
Okay.
All right, now I plug all this into my calculator. So it's really this times 7.
I get this too. I think I hope I get this.
And
Yeah.
the answer is
I got this.
0.323. So let's see. That would be 3.23 times 10 to the negative 1. I still got to deal with that exponent, times 10 to the negative 23 atoms of carbon. And so that would be 3.23 times 10 to the 22 atoms of carbon.
My head hurts.
You got it? I think that will take care of you nicely for
The rest of the week, while we contemplate over the existence
3.4.
of.
Let me just check real quick, which kind of sucks because I think that I assigned homework that is after 3.4.
This mole thing is really
This whole thing
kills me inside.
All right,
Just makes me want to dig a hole in the ground.
I'll tell you what. I will ask.
Get it? Because it was a mole.
No,
moles dig holes in the ground.
I get it.
All right.
I understand you. I dig you. I dig you.
I got it.
I dig it.
I know.
All right. Let me check the calendar. I'll tell you what. I'm gonna take any homework that doesn't have to do with the small stuff, and I'll put it and I'll push it back.
So the homework for today,
I don't know. Is that the homework we do today?
I don't think it had anything to do with moles.
Oh no, molar mass is part 1. Yeah, no, we're good. So on Monday, I'm gonna talk about percent composition, and then we're gonna do some stoichiometry problems.
Okay.
Which hopefully is in here. Let's see. Percent composition is in here.
I know someone gave up on the lab. Don't give up. It's really not. It's not too bad, guys. No, it's not. It's not too bad.
All right. If you don't have iodine for the lab, don't worry about it. I'm just gonna say, don't worry about it. Do the s'mores part. And I'll tell you what. I'll tell you what. I told you I would finish early. Class is now finished. You can go. You are released. You want to push it? Push the lab? All right,
Can we
fine.
push it?
I'll push it till tomorrow. Push it real good. Don't milk it too far. Just do it and then
What?
and then
That
be
was
cool.
that was.
No, but you got to stop. You can't be all like keep going with it.
But that was the whole little course part thing. You stopped on me.
Yeah, I know.
You dished out too early.
That's what I'm saying. Is you got to
I
stop.
kept.
You gotta stop early.
You ducked out early.
No. Look,
No,
I'm the
I
older
kept-
one.
I went through the whole thing. You ducked out early.
I've been around longer than you, son. And
Okay,
what I'm
okay,
saying
okay.
is that you got to just stop and let it hang.
Just.
Don't milk it because it's funnier when you
All right,
stop.
all right, fine. Next time you try to give me a fist bump, I'll just stop and let you hang.
All right. Seriously, if you want to come in on Mondays or on Wednesdays, I think it'd be good. It would be
Wednesdays,
good.
Only
class.
if we get to take 15-minute breaks.
No, we don't
Every
get to
Wednesday.
take 15-minute
That was just a one-time thing.
Maybe I'll think about the 15-minute break. Except on lab days.
No, not on lab days. We got to get stuff done on lab days.
Yeah, lab
I
days
was
we gotta get
just-
stuff done. But
I mean,
I'm just
the 15-minute break was cool, but I mean, if your sixth graders going to act like they
Man, they were crazy.
Were they killed? Did they kill you today?
Yeah.
They gave you asthma,
Well, no, they weren't. They weren't crazy. They're good. I like them. I like my sixth graders a lot.
but they're sixth graders.
No, they're seventh graders. I'm sorry. I like my seventh graders a lot. They're cool.
Okay.
All right. I'll tell you what. Why don't we take a look at this lab?
See, at least the kids who didn't have to come in for the lab, they get to build a fire if they want to roast their.
Bradley, this is Maston.
Hi.
They like you.
That's hilarious.
So check this out. The s'mores lab. I made up a new number called an Anastasio. All right. What? Wait, are we allowed to go after you explain? Yeah, you can go after. Sure, you can stay here while I explain things. I'd rather you stay here while I explain things.
Well,
you can go now if you want.
I don't think I left my lab here. Did you find any labs with
I don't
no
know.
names
I
on
don't
it?
remember. It's not that bad once you're not.
Because if it's not though, it will probably be at home. But if I don't find it at home, what do I do?
You just redo it. I was just gonna say it's not that bad.
Okay.
Is that Celeste? Oh no, it's Geraldine. Okay. Okay, all right. Let's talk about this lab. I made up a new number. It's called an Anastasio number. Anastasio is my name, and I'm extremely. Let's see. Can I put the archive up so I can use this during the lab? Yes, I will put the archive up. I will do it by the end of today.
Okay.
Which I usually do a 24-hour turnaround, but I'll put it all up today. How's that?
I tried to make it to the tutoring thing you did, but it was early for me. Well, I mean, I had other stuff to go do.
It was early. It was only going from 9 o'clock to 11
Yeah,
o'clock.
I had other stuff to do. I had to work.
Yeah. Am I going to explain what I need is needed on the write-up? Yes, we're going through it right now. Okay. I made up a new unit. It's called an Anastasio. Anastasio is my first name, so I'm being very, what is the word? Egotistical? Egotistical. For making up, trying to make up a number and saying, this is now the number, blah, 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 whatever. Okay. So, what I did was I said, I'm going to give you the weight, or the mass of graham crackers, but I'm going to give it to you as the mass of 4 graham crackers, or 1 Anastasio worth of that element.
Right.
Or 1 Anastasio of marshmallows is 29 grams. So technically 1 marshmallow weighs 29 over 4 grams. And this actually goes back to, I mean, there's always a method to my madness, believe it or not. This goes back to exactly what we have on the periodic table. We have the amount of grams for 1 mole of this stuff.
So you're just getting us used to it.
So I'm just getting used to measuring the mass of something as it relates to a grouping of that element.
Right.
And then we have chocolate pieces, and it has 14.33 grams per Anastasio of that. Yeah. If I had a mole of if I had a mole of marshmallows and I gave you the grams of that, you know how big a mole of marshmallows would be? A mole of marshmallows would cover the entire surface of the Earth. A few, like maybe,
are we talking
like
about
20 feet deep? It would be the whole surface of the Earth, including the oceans, 20 feet deep.
That is heaven.
Yeah, I know. It would make an amazing s'more.
Awesome.
It would be like Galactus, the guy who eats planets would be like
Galactus would have a ball.
S'mores.
Galactus would be like, Silver Surfer, you done good.
Yeah, I know. You just pat him on the head. That's it.
Good
All right,
job.
Anyway, and then a mole of chocolate, it'd be amazing.
This would.
But,
oh my goodness.
All right, so a mole of, but so instead of dealing with moles, we dealt with Anastasios, because a mole of actual things is huge.
Yeah.
All right. So what I wanted you to do is calculate the mole of, or the molar mass of s'mores. So a s'more requires 2 marshmallows and 3 chocolate pieces. So you need to take this thing, multiply this by 2, or add it to this times 2, add it to this times 3.
Yeah.
Hey, that's exactly the steps we use when I want to calculate out the molar mass, which is what I just taught you today. Do you see how it all kind of comes together? All right.
Yes, I wish we would have had this lesson before we did the lab.
No, I wish we did this lab before we did the lesson. And that way you can see. Oh, I get the lesson now.
Well, I get the lab, not like I get the lesson.
All right,
well, I got the lab, and
now you feel like you get the lab.
Now I feel like I get the lab again.
Well, good.
We've had this lesson.
So now if you lost your lab at, if you lost your lab, now you can just go back and do it. It's not bad.
Sure.
All right. Balance the equation. Okay, so all I'm asking you to do is how many S's, if s'mores is 1 mole of graham crackers and 1 mole or 2 moles of marshmallows and 3 moles of chocolate, let's balance this equation. So I would need 1 graham cracker, 2 marshmallows, and 3 chocolates. That's it. So the numbers, the coefficients would be 1, 2, and 3. Would make 1 s'more. And actually, Bradley, this probably goes back to kind of what you're freaking out about. Is like you're saying, wait a second, wouldn't that give you 1, 2, 3, 4, 5, 6 moles of something? And the answer's right. But it takes 6 moles of something to create 1 mole of s'mores.
Right.
Or, I'm sorry, in this case we're using the word Anastasia, right? All right.
An Anastasia.
Determine the number of unit marshmallows are available in the bag. If there are 20 grams of marshmallows, how many marshmallows do you have? Okay, or 290 grams of marshmallows. So there's 290 grams of marshmallows. Most people put that they would have 10 marshmallows. Because they look over here. I should probably change this to Anastasia. They look over here and they said, no, I actually explained it over there, so I'm going to leave it like that. They look over here and they say, well, if 1 marshmallow weighs 29 grams, then 290 grams of marshmallows gives me 10 marshmallows, right?
Which is what I did originally.
Which is what many people did originally. But this doesn't represent 1 marshmallow. That represents a giant, fatty marshmallow, which they actually have. In the store, you ever buy those?
Oh, the big campfire one.
They
powdered with more
they're like
marshmallow
huge,
goodness.
right? And actually, I actually don't like those at all.
They're a bit big.
No, they're too big, and they don't ever cook the middle.
Oh yeah, or unless you sit there for.
Yeah, I know. I'd rather get the smaller ones and then roast them because they're quicker, and I can have more s'mores. More s'mores is better.
More s'mores than instead of 1.
Some more s'mores is good. All right.
When you buy eggs, do you buy the 18-pack?
So, really, for step 3, you have 40 of the stuff. Does that make sense?
Yeah.
All right.
It makes sense to me. I already did it, so it makes sense to me.
Now, if you had 40 marshmallows and you had unlimited graham crackers and unlimited chocolate, sounds amazing.
That's a good day.
How many s'mores could you make?
Good, 40 marshmallows.
With 40 marshmallows?
Don't you have to use 4 marshmallows for 1 s'more?
No.
What was the
2 marshmallows, 1 s'more.
1 s'more?
So 40 marshmallows makes you how many s'mores?
I will not say the answer.
20.
There you go.
Very good. Absolutely. All right, step 5. Shoot, I'm just doing this whole lab for you.
Yeah, I know. Like, great, if I lost it, I can just
Well,
go
it's just
back to
'cause-
this archive and look at it.
It's just because Bradley's saying, I got stuck on step 6. Step 6 is the last step.
Oh, well, we kind of need to go through.
All right.
I
Fine.
see what he's doing. This is a smart guy.
Yeah, that's pretty tricky of you.
I
All
see
right.
what you're doing.
Convert your number of graham crackers and your chocolate segments into a mass. Okay, well that's pretty straightforward too, because if you're talking about, let's see, if I have 20 s'mores I can make, that would require 20 graham crackers.
No, so you need 2 grams. No, you don't.
No, well,
You
yeah,
just
that
need
would.
1 graham cracker.
Yeah, you need
break
1
it in 2.
graham cracker. A graham cracker is a long piece that you break in 2. So it would require 20 graham crackers, right? So I told you the molar mass of this thing. So you take that graham cracker and then you figure out, or you say, I need 20 graham crackers. So you multiply this by 20. Is that correct? So you have 20 times 62.
20 times 62.
Which is
yeah.
whatever. Yes. But remember, this number 62 actually represents 4 graham crackers itself. So you take that answer, the 20 times 62, and divide that by 4.
Yeah.
And that's the mass of your graham crackers. So whatever that is. So actually, you're multiplying, instead of multiplying 62 by 20, you multiply 62 by 5. Because 20 divided by 4 is 5. Done.
62.
62 times 5. That's it. Now that's the mass of graham crackers that you have.
Would equal 310.
Okay. So then what I do is I say, all right. See, here's the thing about it, and this actually made sense to me when I went into the store. Is if I bought one bag of marshmallows, right, and you look on the package and it says this contains 40 marshmallows.
Yes.
Then you think,
That's
well,
10
how many?
Anastasios.
How many? No, right. And so I started thinking, well, how many graham crackers do I need to buy? And they don't tell me how many exactly graham crackers are in a box or whatever.
No. Well, there's a pack, and each pack contains.
Yeah. So what I did is they actually do tell me the amount of graham crackers in a box. But what I could do, if I wanted to, is I could just weigh them. You know what I mean? I just take the boxes and put them on the scale and start weighing them. You know what I mean?
Which one's heavier? That's yours.
Well, not see which one's heavier, but see how many boxes I need to get the right weight.
Right. Okay.
So after you get that number from 5, no, this is all up on YouTube. I'm archiving on YouTube. I think I forgot to press the record button. You guys all have to go. Oh yeah, it's 1 minute past my time. After I get the answer from number 5, number 6 is actually the easiest step. Because if I have something like 500 grams of graham crackers that I need, right? And each box is 408 graham crackers, or grams of graham crackers.
Whoa. I wish, man.
Well, no, it is. It's 408 grams. A gram isn't very
408
much.
graham crackers. Oh, well.
Yeah.
What is graham cracker?
Yeah, I know.
A gram of graham.
I know. I
Man,
made that joke already. It was done. We did that, right?
I'm sorry.
I said it up here, or
Really?
right here.
Where?
It's right here. It goes 46.5 grams of graham crackers. Get it? Graham crackers. It's supposed to be gram. GRHAM. All right.
Okay.
So Bradley is saying you need 310 grams of graham crackers.
Yes.
So, yeah, and so we don't confuse ourselves. You need 310 grams of graham crackers.
Graham crackers.
Graham crackers.
Not
Yes, I
graham
know, yeah.
crackers. Graham crackers.
Then I think that you should only buy 1 box of graham crackers. Because then you'll have extra.
You know extra graham crackers? Yes.
Yeah.
You get extra. What do you can you just eat graham crackers straight up, or do you put something on?
So you
graham crackers?
divide by 62? No, why would you divide by 62? No. All right. Maybe this might get. All right. Brad, can I call you Brad? Let's do it this way.
Did.
Let's do it this way, okay? Pretend that you ended up calculating out that you got 900 grams of graham crackers that you needed. No, I cannot. So, okay, Bradley. Pretend that you needed.
Let's say you have 300.
Okay, but hold on. I think this makes sense. All right. Pretend that you needed 900 grams of graham crackers. Got it? How many boxes would you buy if each box contains 408 grams of graham crackers?
So if you need
I'd buy 3.
900, I'd buy 3. And you have
Yeah.
a bunch of graham crackers.
Yeah, you get some left over.
Yeah.
Yeah, I mean, you could be super cheap and be like the old school play where you'd be like, excuse me, manager, can I buy 2? And then if I buy like 3 of these extra graham crackers, can I pay you like 50 cents?
Why did you turn into like a Japanese person?
Well, that's because that's the way the
That's
skit
not-
went. It was
They don't-
it was funny back then.
Okay.
It was like in the 90s, whatever.
It's an SNL skit?
Yeah.
I'll have to look that up.
All right. Anyway.
I think it's 3.
Yeah, it's 3. Absolutely. So you divide whatever number you get by
3.
408, and then you round it off to, or you round it up because you can't buy half boxes. So in your case, you had 310 divided by 408. That's going to be a number smaller than 1. So then you round that up to $1. $1. Done. Yeah, you need $1. Yeah.
$1.
Because you only need 310 grams of graham crackers. A box contains 408 grams of graham crackers. You need $1.
$1. That's your answer.
Then you can share the extra graham crackers with everybody else.
Like we did. Do we have any more, by the way, or did you eat them all already? So I remember we had a lot left over.
I did another lab with another group of students.
Oh. All right. Fine.
I still have some chocolate, I think.
No,
Not
I'm
here,
just
then.
kidding. I'm just kidding.
All right.
Save it till Gritfest.
All right, I'll tell you what. Bradley, I did pretty much all of the lab for you except for this last page. And I do want you to do this last page. It takes some brain work. Got it? So that's the whole lab. Well,
Everyone should get 40 out of 40 on this.
that's the lab minus like a paragraph. No, come on, you can do this.
Let's see what time my bus gets here.
And I'll tell you what. If you figure out how to do this last part right here, don't worry about the iodine clock, all right? If you figure out how to do this last part, and you don't need to eat the s'mores or even make the s'mores yourself. You just need to type in or do all the calculations. But if you do this last part, I promise you this. It will significantly help you out in Wednesday's lecture next week. I might even get to it on Monday. It's the part I have up right in front of you.
Did we have school this Monday?
Yeah, we did.
We did?
Yeah, I had a chemistry lecture. I'm still putting it
Oh,
up.
yeah, that's right. I remember. I was there.
No. I'm not going to give extra credit. I already give enough extra credit. I have like 5 students that have over 100%.
Wow. It's not me. Don't look at me.
All right.
You have over 100%? How does that work? Oh, yeah, I'm making, 107 in Mr. Dollyday's class.
I don't know. I don't actually know how they got over 100%. The computer's grading it.
I'm calling hacks.
And I'm like, all right, fine. I don't mind. I think it's because I've been giving you folks like these teachers credit points, where I'm like, because I make so many mistakes, I give you a teacher's compensation. You guys, you know about that, right?
I know about that.
Yeah.
I was a victim of that.
A victim.
Yes, of the mistakes.
Oh, victim of the mistake.
Of the
Oh,
mistakes.
wow. But now you're also a benefit.
Now I'm also
A benefactor.
making like almost an A in this class. When I get this lab turned in, I will be making an A in this class. I'm very happy.
All right. So I got to go. Class has been over for 8 minutes. I've actually lectured all darn day.
You should really take a nap when you get home.
I'm so sad. I'll talk to you guys later.
Bye, guys.
Hey, dude, you got to come up with the sign off.
Do what?
And as always, stay classy.
I think that is
Stay classy, chemistry.
Rob.